Today's lesson is about whole numbers and fractions. We'll study the relationship between fractions, whole numbers, mixed numbers, and improper fractions. For our first example, let's look at a scenario that's pretty easy for all of us to understand. So we begin with our one whole. And we know that a fraction is part of a whole. But today we're going to take that concept a little further. So let's begin by adding fraction strips to show what one whole would equal. And we see that 2 halves equals 1 whole. But perhaps we want to think of a number greater than just 1 whole. Perhaps we have additional halves. And in this case, again, we have 2 halves to make another whole. So in reality, we have 1 whole and we have a second whole. So how do we represent that on a number line? Of course, we begin with 0. The denominator tells us how to divide our number line into parts. So we would begin at 0 halves, and our first segment would be 1 half. The second segment would be 2 halves, or we can also call that 1 whole. We add an additional 1 half, and now we would have 3 halves. And then our fourth half would be 4 halves, or we would have the 2 wholes. So we can see that sometimes there are numerators that are greater than the denominator. And when we have a fraction with a numerator that's greater than the denominator, we call that an improper fraction. But the main point for today is that when we have fractions that exceed or are greater than our denominators, we have improper fractions, but they can still be represented in fractional form. 0 over 2, 1 over 2 or 1 half, 2 halves, 3 halves, 4 halves, and 4 halves would be 2. So let's fill in our top. This would still be 1 half, and then we have 1. 3 over 2 would be 1 1/2, and 4 over 2 would be 2. You might consider, in the past, I've said a lot of times, we can think of this dividing line as a division sign. 4 divided by 2 equals 2. Let's try some harder examples. For our next example, we will try to work with fourths. So we have our 1 whole just as a marker, an indicator as to what 1 whole would look like, what the representation would be. So we begin with 1/4, and I think you know where I'm going with this to equal a whole. 2/4, 3/4, and 4/4. So that would equal 1 whole. But again, we want to see what it would look like if we had additional pieces. So far we have 1/4, 2/4, 3/4, 4/4, and 4/4 would equal 1 whole. But what if we had more fourths that we wanted to represent? So again, we'll put this 1 whole as a marker, and we'll add. Now we have 5/4, 6/4, 7/4, and 8/4. We have another whole. So we can either write this as having two wholes made of fractions or one whole and another whole. Let's just write right now that we've added on and we have another whole, which would be then two wholes. We'll remove our markers because we can see that we have two whole numbers made by fractions. So now for these two wholes made from fractional pieces, we must represent that on a number line. As you know, the denominator tells you how to divide the parts between whole numbers. And we see that this is divided by fourths. So let's begin. We'll move our ruler and we can begin at 0/4. And then we would have 1/4, and there's our representation. Next, 2/4, going to 3/4. Now we have 4/4. And we know that 4/4 is also represented by 0. Or excuse me, by 1. By 1. Oof, I was thinking of writing a 0 over there. And now we'll continue on, now that I'm back on track. An additional fourth would give us 5/4, and then 6/4, 7/4, and 8/4. And we see that when we have two parts that have 4/4, that would be the whole number 2. So our number line, we maintained representing the fourths on this number line: 0/4, 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Now let's look at how we could represent that using whole numbers as well as fractional numbers, which would be mixed numbers. And you will recall that lesson from last week. So we begin at 0, and then of course 1/4 because we don't have a whole yet. 2/4, which could also be 1/2, but that's for another day with equivalent fractions. 3/4, and then we have the one whole made of 4/4. Considering the second line of fourths, now we would have 5/4 or 1 and 1/4. Adding in another, we would have 1 and 2/4. Another fourth would provide us with 1 and 3/4. And the two rows of fourths together would be 2 wholes. Again, 8 divided by 4 equals 2. 4 divided by 4 equals 1. So we can see that this line can work as a division sign, and it would provide the mixed numbers above. Let's continue on with this thought. Our final example in today's lesson is going to be working with sixths. I want you to think, how many sixths would be required to make one whole? I have a feeling you know, but let's just verify that with our fraction strips. 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. I'm sure that you probably knew that. You've been working with fractional strips for quite a while and creating wholes. So we will call these 6/6 one whole. Next, I think you probably again know where I'm going with this. Perhaps I have more sixths available to me. So again, my one wholes are just markers to hold my place. so that I can focus on the correct number to create a whole. So now I have 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6. So once again, these fractional pieces have created one whole. So we'll write one whole by these 6/6. I'll remove our holders, our one wholes, because they're no longer necessary for our lesson today. So now it's time to represent on our number line. We have 6/6 in the top line of fractional pieces and 6/6 in the bottom line of fractional pieces. What determines how a number line is broken into parts? If you said the denominator, you're 100% on track. So let's begin with 0/6, which is also 0. And then we start with our 1/6, move to the next piece, 2/6, 3/6, 4/6, 5/6, 6/6, and since we know that that completes one whole, we'll go ahead and just write a one whole above that position on the number line. Now we move into our next row of fractional pieces. Beginning at the left, that would be then 7/6, 8/6, 9/6, 10/6, 11/6, and 12/6. And as we completed this second row of 6, we see we would have 2 complete wholes. So we can also say that this is 2. So counting through our 6, let's start from the beginning. We have 0/6, 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. It's a bit of a tongue twister. Let's work with our fractions and mixed numbers now. We'll write those across the top. So 0/6 is the same as 0. 0 divided by 6 is 0. And then we again have our 1/6. It's the same because it's a fractional piece. 2/6, 3/6, 4/6, 5/6, and then 6/6. 6 divided by 6 would be 1. And we already put our 1 because we saw that 6/6 equals one whole. Now 7/6 would be 1 and 1/6. 8/6 would be 1 and 2/6. 9/6 would be 1 and 3/6. 10/6 would be 1 and 4/6. 5/6 would be 1 and 5/6. And 12/6 would be 2. 12 divided by 6 is 2. So we can represent our fractions in fractional form throughout a number line, and we see that we changed into improper fractions between 1 and 2. Or we can represent our fractions using fractional pieces and then also mixed numbers. So always read the directions carefully to be sure that you fill in the correct response. Sometimes, as you're doing math in the future, the request will be fractional form. At other times, the request might be fractions or mixed numbers. And we learned that a mixed number is a whole number with a fractional component, a whole number and a fraction. So always work slowly and be sure to ask yourself, what question is being asked and how should I respond correctly? That concludes today's lesson. As always, I suggest to you to be thoughtful and consider the question being asked in every math problem. Think about whether you're looking for fractional pieces, improper fractions, mixed numbers, or whole numbers. With practice and perseverance, you will succeed in learning all of the concepts involving fractions.